All right, so since we're all here, we'll just go ahead and start. Last time we left off talking about variables and operators. And just like C, I don't know about MATLAB or not, but just like C, it's a statically typed language, which means that you have to declare a variable before you can actually use it. If you don't declare a variable, of course, then you can't use it. For example, I've declared a variable x here to be of type integer. And so I can use it. I can say something like system.out.println x, right? But I've not declared a variable of type y, right? So if I said y is equal to 12, that would be a syntax error because I've not defined what its type is. It's not an integer, it's not a double, it's not whatever. Likewise, if I just start using it and say x is equal to y plus 10, right? Then it doesn't know what y is because y has not been declared, it has not been initialized to any value or anything like that. So let me go ahead and create that variable y and set it equal to 10, right? Actually, let me go ahead and not set it equal to 10. Let's print out x and let's print out y, right? Now, you might be asking yourself, why is that a syntax error? Right? And it is a syntax error because, it's correct code, but it's a compiler error because y has not yet been initialized. If you were to do something like this in C, what would it end up printing? Likely, probably 0, right? Although it could be garbage, or sometimes we call these things dead beef, right? Because in hex speak, x dead beef, right? You can use a hexadecimal. A hexadecimal is 0 through 9, and then A through F as well, because it's base 16. We count in base 10, but computers count in base 2, and you can also convert it to base 16, which is hexadecimal. And dead beef is a way that you can say that this is uninitialized memory. Right? In C, uninitialized variables are allowed, but what the default value is that is given to that variable is undefined. So it could be 99 times out of 100 it'll be 0, but it's that one time out of 100 that it'll be some dead beef value or some random value, especially on Windows systems. So Java is not even going to let me do that. Java means forces me to initialize a variable. If you want it to be 0, fine. You have to explicitly say that it's going to be 0. Right? So there are no default values with respect to variables. Let's go ahead and miscellaneous here. Miscellaneous. That Java is a statically typed language. That means that all variables and their type must be declared before you can use them, right? And also it has the same scoping rules as C, right? In other words, variables declared in a block are only exist in that block, right? So you can have variables of the same name in different blocks. Here I've got a main and I've got an x and a y. If I created another a function, let's just say public static void foo, right? Foo is our placeholder. Foo, bar, and baz, those are our placeholders in computer science for nonsense, basically, right? I don't have a name for this function, so I'll call it foo. Int x is equal to 10 and int y is equal to 20. Are those the same x and y as these x and y's? No. Because they're in different functions, they are in different scopes, okay? If I passed in x and y over here, then I would actually have three different x's and y's now, x and int y, right? In fact, it won't even let me do that here, right? But if I do, say, a and b, call them different things, then of course I'm allowed to do that. And if I call foo on x and y, right? Though I'm not passing in the variables x and y to this function, I am passing in the values stored in those variables, 42 and 0. Right? Unlike C, where, say, C you have something like this, public static void bar int star a, int star b. Right? Do we remember what these things are in C? Obviously, it's not going to compile here because in Java we don't have pointers. We'll get to that later. But that is a pass by reference function. You are passing the memory address of the variables A and the memory address of variable B. You did pass by reference, right? Yep. Okay. We don't have that in C. Right? These are not the same variables because they exist in different scopes. Right? They only exist in the block in which they're declared. Right? And finally, there are no default values specified for variables in Java. Right? You are forced to initialize them to some value. Right? Okay? You can't just go and use them. Otherwise, it will be a compiler error that it's an uninitialized value. Right? Right. Yep, we're good. All right. Okay. So now, standard input and output. When we mean standard input and output, we mean the standard output is going to be the console. So what about the standard output? Well, we've already seen a couple of examples of this, right? Printf, that prints a line. Print just prints with whatever you give it without a line. And then you can also use your old friend printf from C. Right? So if I've got multiple variables here, let me go ahead and get rid of all this stuff here. And different variables here, x, y is equal to 3.14159. String s is equal to me, my name. Right? You can go ahead and system.out.printf, right? And use the same formatting that you would in printf in C. How do I print an integer, by the way? %d, right? How do I print double? Oh, okay. You can go with lf, which is a long float, or you could just go with f with respect to printf. And then what about a string? S, yes, it makes sense, right? The other two don't really make sense. I guess f for floating point numbers, but d for integers, not doubles. Yeah, x, y, and s. Right, there we go. And when I do that, I get the exact same behavior as printf in C. 1, 2, 3, 4, 5, 6 decimals of accuracy by default. How can we change that default? What if I only want 2 decimals of accuracy? Dot 2, right? And what if I wanted, I don't know, even more? What if I wanted 20 decimals of accuracy? First of all, does that really even make sense? No, because a double is going to be 16 digits of precision. If you print out, I don't know, 200 decimals of accuracy, you're probably likely going to just get zeros here, but you're just as likely to get garbage as well, right? Because there are only 16 decimals of accuracy. Okay. If you want more or less accuracy, right? You can align things as well by providing another placeholder here. Let's kick this back down to 2. If I wanted, I don't know, a minimum of 10 columns there with 2 decimals of accuracy, what is that behavior? It pads it out with 6 spaces. Because there are 3.14, there are 4 columns there basically for the number. And then I want a minimum of 10, so it ends up padding it out with a bunch of spaces. This is how you can get things to line up and look really, really pretty if you want. Okay. Yeah?
So with the other printing options, you can't format, you can't print out.
Are you sorry again?
So like you got print out, but then you have print.
Oh yeah, print ln and print. Those just print strings, right? Or integers converted over to strings for printing. Yeah. Yep. So put that so that you have a reminder of what it looks like in C as well, but Java here. By the way, every programming language is going to support printf style formatting, including the weird one, Python. Only in more recent versions did they introduce F strings. F for printf formatted strings. Right? All right, well, what about standard input? Remember that the standard input is the guy mashing the keyboard. Okay? So how would you do that in C? What if I wanted to read in an integer here? Let's write an entire program here. Print system.out.print or println. Please enter an integer. We want them to mash the keyboard and give us an integer. Okay. If you were in C, what would you do? Scanf. We have something similar called a scanner. Right. S is equal to new scanner. And what are we going to be scanning? Well, this scanner is actually general purpose. Later on, we'll scan files. But for now, we're going to scan the standard input, the keyboard masher, system.in. Right? And to bring this in, I have to import scanner because it's in this java.util package. Right? All you need to do to import something is hover over it, and then it'll generate the code for you. Or you can write it explicitly up here. You have all this in C as well. How do you bring in an external library? Include, right? Here we're doing import. Okay. Now that I've got my scanner, I can scan it. S dot, give me the next integer or next int, right? So that I will read in X, right? Print system.out.println, you entered, and then I can concatenate X here, or if you really, I prefer personally the much better way of %d end the line, and then like the C style stuff, right? So there we go. Please enter an integer. Now I do have keyboard input here. All I have to do is make sure that my console is highlighted, and then I can start mashing the keyboard. Standard output, you'll notice immediately that it's printed in black. Standard input is printed in green. That's obviously not a number. So let me go ahead and enter in an integer that is correct, 5, right? You entered 5. What if I had mashed that keyboard? Please enter a number. Does that look like any number you've ever seen? No. So what's going to happen? In C, what would happen with scanf? It would see that D, and it would immediately say, stop and say, okay, what have I scanned so far? Nothing. What is the numerical value of nothing? 0. Different. Now I've got red, and red means error. That's the standard error. Standard output is black, standard input is green, and standard error is a bunch of reds indicating an error. Input mismatch exception. I tried to read an integer, an int, but you didn't give me an int, so it threw an exception. We'll talk about exception handling later on, but that's a fundamentally different way of handling stuff than you've done in C, which is probably defensive programming. You look before you leap. Are you about to divide by 0? If you are, do something else. Right? This is an exception. Something bad happened, and it throws this exception that you can catch, and then decide how to deal with it. We'll look at that later. But if you wanted to read in a double instead, double y is equal to s dot next double. Right? If you wanted to read in a string, it would be like just dot next. Right? And so you entered y. Right? So let's run this program again and look how it's interactive here. So enter an integer 10, right? You entered 10. It is still running, by the way, because the stop button here is active. Right? So now I'm able to, I didn't have another prompt here asking you, all right, now enter a double, but I could have put that there. Now let's go ahead and enter in a double, 3.5. Right? There we go. Okay. Now the program is done because the stop button is no longer active. Okay. So there is your interactive input. Now a lot of you are already done with the lab. Great job. I actually checked it this morning, so maybe more of you are done, even more of you are done it with it now. But we changed over to, or we had you change over that statistics program, that demonstration program, to command line arguments. Right? Now in C, when you run a command line argument, you're running that a.out file, and then here's your first argument 10, here's your second argument 0, here's your third argument 3. Right? There are actually 4 arguments here. The first one is the executable file name. We don't have that in Java because what is the name of my executable file? Demo, right? I've already given it a name, so it's not going to be included in the arguments. Those arguments are right here. Now we don't have argc and argv. It's just one thing, args. Okay? So how do we start using this? So what I'm going to do is I'm going to say printf, or system.out.printf, println, you entered let's go with f, %f, right, %d arguments. There we go. So what is that %d going to be? Args.length. This is actually an array, and you're familiar with arrays. It's got these square brackets. It's not a pointer, right? It's technically a reference, but we're not going to be treating them as pointers. And there are a bunch of strings. How many of them are there? In C, what you would have to do is you'd have to keep that in track in another variable, right? If I'm going to hand off an array to a function to sum up all the elements, I also have to tell that array there are 5 elements in that array to sum up, right? But here you don't have to do that because it keeps track of the length of the array directly in the arguments, or directly in the object, basically. Right? And now I'm going to write a loop, a for loop, for int I equals 0, I is less than args.length. We call these idiomatic for loops because you're always going to be writing these over and over again. For int I equals 0, I is less than n I plus plus, right? And I will print out the argument, system.out.printf percent args of percent d is equal to percent s because it's a string, right? And we'll go ahead and go args of I. There we go. Right? Now, if I were to just run this, of course, I entered 0 arguments because I didn't actually type out a.out, A, B, C for my arguments. Right? The way that you do that in an IDE, as you probably saw in your lab, is you have to have a run configuration. Right? You go over to arguments and you put whatever arguments that you want, 10, 20, 30, and hello. Right? We'll go ahead and apply that and run it. And there we go. You entered 4 arguments. Right? What's wrong with this? Oh, yeah. Percent D. Oh, sorry. I forgot I. I had 2 placeholders there. That one right there and then that one right there. I was trying to print out the index and the argument there. Now it'll work. So run it again. 10, 20, 30, and hello. I could have made that a little bit prettier by going to the next line. Okay. There it is again. 10, 20, 30, and hello. So the first command line argument is not the executable file name. Right? It is the first actual user provided argument. So you can check to see if there are enough command line arguments. Right? Is args.length equal to 4? I'm expecting 4 command line arguments or something. Right? How about conversion? I want to convert that first command line argument over to an integer. Right? Because these command line arguments are simply strings. How did you do that in C? How do you convert a string, say 42, to the value 42, an integer? Do you remember? Did you never do that, maybe? Alphanumeric. You could parse it, but that's overkill because there's a function there for you to do it. I want to convert an alphanumeric value to an integer. A.I? You might not have used it. Okay, if you didn't use it, that's fine. Of args of 0. Right? Sorry, that's in C. Here's how we do it in Java. Integer.parseInt args of 0. That's the first command line argument. And that will give me an integer to work with. What if I wanted to convert the second command line argument to a double? Double y is equal to integer, or sorry, double.parse double of args sub 1. Right? Now let's add them together. Double x plus, or double y z is equal to x plus y. System.out.println z. Right, so the first argument is going to be 10, second argument is 20 here, which will be converted to 20.0, and the result ends up being 30.0. Okay. How do I convert a string to a string? Well, it's already a string. You don't. Right? You can convert a string to an integer. You can convert a string to a double using this convention. Okay. Really quickly, here, let's see, let's move over here. Let's actually get these into the notes, right? CLAs, which are command line arguments, right? Very quickly, you'll realize that there are no interactive programs really, right? Except if it's a consumer-facing thing, and then you're talking about a graphical user interface for consumers. The vast majority of software is written for other software, so that you can take this system and make them speak to each other. In other words, we write software for automation. There's not somebody sitting there mashing the keyboard all the time. Command line arguments are the way of passing in data from one program to another. Yeah?
Are command line arguments always strings?
Always strings, because if I make this int, now it's an array of integers, but it ain't runnable anymore. Right? Right. There's no main method anymore because it does not follow that signature of having strings as arguments, or string as arguments. Right. Yeah.
Just one more question.
Yeah.
Earlier you had, I think it was when you had a scanner, it was
Oh, yes, we'll talk about that later on, but that's how you create something. Scanner S is equal to new scanner of whatever, system.in, right? This is basically kind of like a malloc. I want you, it's directing Java to create a brand new scanner for with those arguments. It automatically allocates memory, so it's not exactly like malloc where you're allocating memory, because allocating memory is much more simple. Here's your chunk of memory, do with it whatever you want with it. This is actually creating a full new object. Yeah. Okay. Sure. All right. You can also do some mathy stuff. Right. So Java automatically imports the math library. In C, you would have to say import math.h, right? That's automatically done because it's part of this package, java.lang, lang short for language. Right? It's automatically imported because it's part of the language. And you can use it as long as you use math in front of it, right? So for this math right here, and then a dot to call any math function. What if I have, let's say, double x is equal to 2.0, double y is equal to, how do I do the square root? Well, if it was C, it would just be square root after you imported the math library. But square root is no function inside this class. Remember, it's a class-based object-oriented programming language, which means that everything is a class or belongs to a class. This square root function belongs to the math class. So you have to call it correctly, math.square root. Right? What is the square root of 2? 1.141 something? Let's go ahead and try this. All right, there we go, 1.41. Right? Well, what other things might you have there? What if you wanted to do y is equal to math dot, oh yeah, there's an IDE trick, math dot. It pulls up everything that's part of that class, okay? What's the first thing that you see that's part of that class? E, right? That's the Euler constant, right? Euler constant? Euclid's constant. I forget which one is which. Is it Euler? Okay, it's the Euler's constant, 2.71, right? Pi, right? That's the constant, 3.14159, dot, 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 dot. Don't roll your own pi, right? If you write out 3.14, it's not going to be as accurate as that one. Anything that you write is not going to be as accurate as that one. That's the most accurate that's representable by IEEE 64-bit float, right? What is tau? The double value that is closer than any other to tau of gamma, the ratio of the circumference of a circle to its radius. So in other words, it's double pi. Okay. Otherwise, we've got abs for absolute value. Right? Let's do the absolute value of this. Well, what's the of x, say? Right. And then let's make this negative. I'm going to cross my fingers there. Why? What's going to happen? So let's go back up here. Negative 2, try to take the square root of negative 2. Can't do that, right? What's going to happen? Nan. What does nan stand for? Not a number, right? And then we've got the absolute value over here too. It's not an error, right? It's black, it's standard output, right? It's just not a number. Not a number plus 5 is not a number, right? You can also get positive inf infinity and negative inf infinity, negative infinity. But otherwise, you've got absolute value. What else do you have? Dot, arc cosine, right? Arc tangent, arc sine, ceiling, right? Cosine, exp, floor, et cetera, log base 10, min, max, dot, 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 right? So you've got this entire math library to your at your disposal. Right? Okay. I don't know, what's your favorite math, your calculator function? Sine? All right, there you go. I don't know, what's sine of negative 2? Apparently. Actually, that's a good question. What if I set this to pi? What's sine of pi? 0? Right? It's very, very small, right? It's not going to be exactly 0, right? It's a floating point number here to the negative 16th. So it's extremely small. It is essentially 0. That's because computers have floating point errors, right? But the other thing that I would draw to your attention, you said it was 0. Well, that, I guess, yeah, you're thinking in degrees or radians? Radians, which is exactly what you should be thinking in, because this is also radians. So if you've got degrees, you need to convert it to radians and then use these math functions. Exactly the same as C. And by the way, here's a super secret. There's the sign. Right? There's the sign. Let's compute that. Oh, I guess it does do it here. Oh, no, it doesn't. There we go, kernel sign. Okay, I guess it does. Never mind. Anyway, I was going to say that at some point, what is it called? Not strict math, but native? There we go. Okay, so apparently I'm wrong in math. But anyway, at some point, Java is not actually computing the sign. It's making a call to the C standard libraries. Right? You're going to find that this is true of most programming languages. Python doesn't write its own sign function. It calls the C library function. MATLAB doesn't have its own sign function. It just simply reuses the C library functions. Right? Right. So there's your mathy stuff. Right? And do be careful because of not a numbers and other issues that might arise from them. Okay? So mathy stuff. All right, any questions so far? Because this is basic we've gone through basically the first kind of 2 weeks of a CS1 course for Java. Right. No? Well, here's week 3, conditionals. Right. Cut, paste all your knowledge from C, and you'll be good. Right. It is a C-style syntax language, so we of course have if-else-if statements, right? If-else-if statements as well, right? There is no syntactic difference, exactly the same as C. And probably, I imagine, same as MATLAB too, true? Right? However, Java is a little bit richer programming language. Richer programming language, in other words, it can afford actual Boolean variables. Java has real Boolean variables, right? Boolean in syntax, special syntax there. Right? So what I mean by that is, what if I wanted a flag value to say somebody is a student? Right? How would I do that in C? I'd have to make that into an integer value, right? And I'd have to set it to 1 for true, 0 for false. Unless I brought in the standard Boolean, did you do the standard Boolean library? std bool, okay. All that's doing is it's making macros to 0 and 1, to true and false, right? Here, it's an actual Boolean, because if you try to use this, if is student system.out.println discount nav tickets, right? They're playing St. Cloud this weekend, aren't they? All right, nobody follows hockey. No, you know hockey is awesome, right? All right, so it's not going to compile. Why? Because this ain't C, right? We need an actual true Boolean variable to use it as a flag value like that. Not only that, but you can't set it to 0 or 1 by convention. Instead, you set it to true or false. Both of those are keywords in the language, and both of them are all lowercase. Okay? So do they get a, nope, they get else system.out.println minimum $40, which is why I don't go. Right. There we go. Nope. Oh, did what? Sorry, what did I do?
That little trick you just did.
Oh, I just pasted and fixed it. Right. I highlighted, Control C, copy, Control V, paste. I'll show you some other tricks though here that are even cooler than that. Right. All right. So let's say that they are a student. There we go. True. You get your Mavs discounts. Do you get free tickets? Oh, you get free hockey tickets? No wonder they charge everybody else so much. All right, so let's go ahead and say that int Mavs score is, so that they pull a hat trick there. Right? some guy pulls the hat trick. And then St. Cloud, score, they only get one. Who won? If the Mav score is greater than the St. Cloud score, then who won? Mavs win. There's my if condition. What's another if condition here? What else could happen there? The Mav score could actually be strictly less than the St. Cloud score. Right? In which case, who wins? St. Cloud wins. There. Right. And what's the only other possibility there? And it is a possibility in hockey because you go to overtime or a shootout. Right. Okay. So Mavs won in this case, and so it'll only print out Mavs win. What if, unfortunately, that score were reversed and it was 1-3? St. Cloud wins. What if it was 2 hat tricks there? Oops. We go to a shootout. Okay. I don't like that variable name. Here's one of those tricks. I don't. Maybe they're not playing St. Cloud. Maybe they're playing somebody else. Maybe they're playing, I don't know, Ohio State. Ohio State. I gotta change that in 3 different places now. Don't do that. Highlight it, right-click it, refactor, rename. Ohio State. It changed every single instance that was in that scope. Right? So if you want to rename a variable, just go up to where it's declared, rename it for the entire file. Right? Again, highlight, refactor, rename. Right? Okay. So there are your conditionals in Java. Oops. Come on. Sorry. Got to get it formatted for the notes correct. All right, there we go. You can use the, you have built-in Boolean variables, and of course you can use the keywords true and false as well, right? Again, all lowercase and spelled correctly, right? And they are case sensitive. Complex statements can be rewritten using logical operators. For example, what's the logical AND operator in C? Ampersand, ampersand, right? What's the logical OR operator? Pipes or vertical bars or Sheffer strokes, whatever you want to call them, vertical lines. We generally call them pipes in Unix, or in the tech world, because in Unix you can use them to pipe one command into another command, and so it's like a vertical pipe. Right? Let's see. And then how do you do the negation? Logical negation there.
Exclamation.
Yep, exclamation point. I don't know why it's not. Let's try that. Okay. I have no idea why it's not formatting correctly, but wow, that's really screwed up. Let's just try that. There we go. Okay, logical and, or, and negation. And then numerical comparisons, right? Less than, strictly less than or equal to, strictly greater than or equal to, equals for strict equality, and not equals for strict inequality, right? You cannot use these for string comparisons, right? I mean, you can, but it will give you different results, just like C. You can't do this in C. And what I mean by that is, let's look at apples and oranges. Right? String A is equal to apples. String B is equal to oranges. Right? Which one comes first? Apples, right? Because it's like the dictionary. So if A is less than B, right, then system.out.println apples before oranges. There we go. But it won't even let me compile because these are numerical comparison operators. These are not numbers, these are strings. You could do something like this in C, but it ends up being a comparison between 2 memory addresses, not between apples and oranges, the 2 strings. That it ends up being a number in some random number in memory over there and some other random number in memory. And that's not really what you want to compare. We'll talk about string comparisons later on, but the takeaway is that you cannot use them for string comparisons because it doesn't even compile, right? You also have short circuiting. Did you cover short circuiting? So for example, if suppose you have let's see, A and B, and A is false. Does it matter what the value of B is? Nope. So short circuits, it doesn't even look at B, right? Another one example, suppose you have A or B, and A is true. Does it matter what the value of B is? Nope. It ends up being true no matter what, because only one of them has to be true. And as a consequence, come on, it is not formatting well today at all. I don't know why. It will once it's on GitHub though, I'm sure. All right, so that's short circuiting, and it comes into play later on, especially if you've got, you want to make sure that it short circuits, and you don't want to look at the second condition. We'll look at some examples of that later on. Right? Let's see. All right, so week 4 of a CS1 course would be loops. Right? Java supports the usual for and while loops. It also does do while loops, but I don't cover those generally in and even in a CS1 course because it's better. Philosophically, I think it's better to rewrite a do while loop into a just regular while loop because it cleans up the logic, and then you only have to worry about these 2 loops. So let's go ahead and do some. Right? So if I want to count to 10, right? For int I equals 0, I is less than n I plus plus, right? And so I'll set n here to be some value. Int n is equal to, I don't know, 10. And if I system.out.println I, that index variable, what values is this for loop going to print? I initialize it to 0, right? So the first value is going to end up being 0. Then it goes up by 1s, right? Same syntax as C and probably MATLAB as well. What is the last number that gets printed? 9, because it's strictly less than 10. Right? If I wanted to go up to and including that value, there you go, 0 through 10. Right? If I wanted, I'll go ahead and remove that. What if I wanted an equivalent while loop? While I is less than n, system.out.println I. Uh-oh. I don't know what I is there, right? Why? It's scoped to this loop, this for loop. It only exists for this for loop. So if you want that I later on, you need to declare it and initialize it. I'll initialize it to 0. While it's less than n, print it out. I'm about to hit this play button. What's going to happen? What? It's going to keep going, right? It's an infinite loop. 0, 0, 0, 0, right? When that happens in Eclipse, when it happens in the command line, you can always go Control-C to kill it. Here, it's more graphical. There's a stop button. If you started the program with a play button, you can stop the program with the stop button. Okay? The problem was we never made progress towards our terminating condition, I++. Now, when we do that, we get the same behavior as the while loop, or the for loop, excuse me. What if we had done it on a different order? And this kind of highlights the main difference between the for loop and a while loop. I'm just putting a separator here. Right? So there's the for loop, 0 through 9 as before, but here we start at 1 and go through 10, right? Because we ended up incrementing the I before printing it out. That's the difference between a for loop and a while loop. A for loop is very prescribed, right? The update always happens at the end of the loop. Here, with a while loop, we have freedom. We could do it at the beginning of the loop. We could do it at the end of the loop. We could do it, if I've got like 10 lines of code in there, I could do it in the middle, right? So the while loop is a little bit more flexible, right? But otherwise, that's the main difference. Okay. All right. So here's your example into the notes. All right. Let's see. Okay. Generally, what are the instructions I give in CS1 for which one should you use and when, right? Are, oops, sorry. Come on, undo. It's not accepting my keystrokes today. Generally, you use for loops when you know up front how many iterations you're going to go. Here I've got an array, and I know that there are 10 elements in the array. A for loop is best because there's no thinking, right? But if you don't know how many iterations you're going to go for, then let's go ahead and write a while loop. And the quintessential example that I usually give is, let's go ahead and have int n is equal to, let's mash the keyboard, there. How many digits are in n? Well, we can see that because I just wrote it out. There are 8 digits there. But I want to write a program to do that for me. Because if I ever come in and add another digit, then I want that program to now report 9 instead of 8. Okay? How many digits are in n? Any ideas for how to go about doing this? Okay, so if I could convert it to a string, right? And the way that I would do that is string s is equal to new string of n. That will convert it, it's a string dot toString n. I think I can do that. Nope, I would have to do integer dot toString. And then I could say system.out.println s dot length. There we go. We haven't really gotten to strings yet, but that's one way of doing it, 8. In fact, that's a better way of doing it than writing your own loop to do it. But I want to write my own loop to do it because I want some practice on loops here.
Would you parse?
It's still not a string though, so I can't parse anything. But what if I were to take away that 8 and keep a counter in my one hand here, right? Then I took away that 7 and I incremented my counter on my fingers here. And I kept doing that until, and now I've got 8 fingers up here, until I got to nothing. In other words, 0. Right? 1, 2, 3, 4, 5, 6, 7, 8. Oops. What was I effectively doing there by taking away the 8? Here, let me write it another way. Dividing by 10. Now, if I do integer division by 10, what happens to that 0.8? Truncation. Right? So, while n is not equal to 0, I will say n is equal to n divided by 10. Right? And I'll keep a counter, plus plus. Where will I start my counter? At how many digits have I read up to this point at line 13? None, so what's the numerical value of none? 0. Right? And then at the end, system.out.println counter for the number of digits. That should be 8, good. If I add another digit there, that should be 9, good. Let's take away most of the digits. That should be 4, yay. What if I added all the digits? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. At some point, it's not going to let me do that anymore because there's a maximum value to integers, 2.147 billion, right? And so what could I get away with here? 1, that's too big, right? That should be 10, right? 10 digits. Okay. Why did I use a while loop there?
So that you can change the value of variable.
Right. Philosophically, though, I didn't know how many. How did I know how many iterations I was going to go up front? If I knew that, then I'd have the answer, right? That would be the number of digits. Right? So while loops are used when you don't know up front how many iterations you're going to go for. Right? I don't know if you want that in the notes or not, but I'll go ahead and put it in anyway. All right. Okay. Java also has what are called enhanced for loops. Right? More on that later. Right? They're essentially for each loops. I'm not putting that into code mode because for each is not a keyword in that language. Okay. Instead, you use a different way of doing it because we're going to use them on arrays and collections, right? Java does support basic arrays, right? There is no malloc and no free. In other words, no memory management. There are no pointers, right? There are no explicit pointers, I should say. There are references, of course, but you don't never actually deal with them, right? It's exactly the same, but in order to create an array, you use that, you use the new keyword that you were asking about, right? So let's come over here and create an array of, I don't know, 10, right? 10 integers. Int ARR is equal to new array, or new int of size 10. Right, there we go. That creates a new array called ARR of size 10 that can hold integers. Right? If you try to assign something that is not an integer to it, you can assign 10 to the first one. What about the second one? How about 3.5? The compiler is going to catch you on that. 3.5, is that an integer? Nope. So you're going to have to change that to 3.0, right? Or not, or 3, excuse me. Right? Even 0.0 is not allowed because, well, that's a double. I'm not going to convert that for you. Right? In C, there are all these arcane automatic conversion rules, but nope, in Java, you've got to be explicit. Right? Okay. What if I tried to do this? How big is that array again? 10. What are the index values? 0 through 9 because we start at 0. Right? It compiles. Right? What's going to happen? Index out of bounds exception. What would have happened in C, by the way? A lot of different stuff could happen. It could be a bus error. It could be a segmentation fault. It could be a memory corruption that doesn't matter, right? It could be a stack smashing event. It could be many, many different things, right? You're basically, it's that old friend, did you talk about undefined behavior in C? Undefined behavior is anything that can go wrong, right? We don't define what happens there, so anything can happen. That will be an index out of bounds exception though. Likewise, if you'd put it at like -1, right? That's also an index out of bounds exception, but it's perfectly fine to code it that way, right? But it ain't gonna work, right? Yeah?
So suppose you ran this code without knowing how it is now. What's stored in array?
Good question. Let's go ahead and write an idiomatic for loop here for int I equals 0. I is less than 10, but I don't hard code 10. I go array.length because that tells me the length of the array, just like the args array that we did earlier. I++ system.out.println. Oops, I forgot my semicolon there. Let's go ahead and go with array sub I. All right, now the first one that gets printed is going to be 10. The second one that gets printed is going to be 3. That's pretty clear. Right? All zeros. Wait a second. Didn't you just say that if you create a variable, you have to set its value? Yes, for variables. For arrays, no, there is a default value. That default value is 0. Because they don't want you to have to go through every single array and initialize them all to 0 yourself. Right? That is a defined behavior. In C, you're throwing the dice and seeing what happens. Right? Here, in Java, it is a defined behavior. It's always going to be 0. Right? All right. So let's bring that all over to the notes. And note what we just said, that invalid index values result in a index out of bounds exception, right? That the default values of an array are zeros. And this could be, if it's a 0 for an integer, likewise if it's a double, then it would be 0.0. Likewise, if it's a Boolean, it would be false would be your default value if you created an array of Booleans for whatever reason, right? Okay. Cool. Yeah, and then and then the other observation is the size of an array can be determined using array.length, right? Note there that there are not any parentheses. That is what's called a property, and it's just dot length. Yeah.
Suppose you want to make an array, but you don't know how big that array is going to be.
So generally, you would read that in as a variable, right? N, right? So int array, let's do a double array this time. And let's call it bur, because B comes next, right? Is new double of N. So you can make variables like that, right? You don't have to hard code it like that. Right? Does that answer it, or?
Yeah, so basically, like, say N is dependent on what you...
Yep, exactly.
You just add N equal to the scanner.
Yep, exactly like you did in your, well, I guess we gave you the code to do it yesterday in your lab when, please enter in a number N that you want to enter the statistics for, 5, right? And then it created an array just like this using N, right? Okay. But you know what? Actually, arrays suck, right? Once created, they cannot grow. They cannot shrink, right? You have to still manually do a lot of work. Not a lot as much work as C. Like C, you have to do all the bookkeeping yourself. You have to do all the memory management yourself, right? Those are taken care of in Java, but I mean, what if, for example, you said, all right, I'm going to read in 5 integers and I make it of size 5. Oh no, now later on in the program, I have a need for 6 integers, right? Can you grow that array? In C, there's a function called realloc where you can try to reallocate memory and grow the memory, but there's no guarantee on that, right? Over here in Java, we have a much better solution. Better solution. Dynamic data structures, including a list, a set, and the best of them all is called a map. Right? And we're going to talk about all of these here shortly. Right? Yeah, we got it. I'm down to what percent? 19%. Okay. OBS is a hog, so I'm going to have to plug in now. I should have done that to begin with, but. I'm actually quite impressed that it didn't die already. We went, what, 50 minutes on not even a full charge, but OBS was taking a lot. All right, there we go. All right, so now we're cooking. Even if I got down to like, 10%, it would start throttling, and that would not have been good because then it would have been juddery. Right? All right, so let's talk about lists first. Lists. Right? A list is a data structure that holds elements in an ordered manner, allows duplicates, and grows or shrinks automatically as you add or remove stuff. Right? Awesome, right? Because now you don't have to do any of that work yourself. Let's take a look at how it works over here. I don't want those arrays anymore. Once you start using lists and sets and maps, you will never go back to arrays, right? Trust me. I want a list of integers, right? And I'll just call it numbers, is equal to a new array list of integers. Right? Now, all of these data structures are in java.utils. So you do have to import them all. Java.util list and java.util array list. We'll understand this a little bit more when we get to object-oriented programming, but there's some new syntax right here immediately, right? This is called parameterization. If I didn't have this, what is this a list of? Despite the name, I could have called it X, right? Or Z, right? What is this a list of? Anything, right? That's bad because now you can put integers in there. You can put doubles in there. You can put strings in there. It's chaos, right? So I'm going to go ahead and parameterize this to say that this is a list of numbers, of integers, excuse me. Right? I can add whatever integers I want. I can add 10, 20, 30. All right? 30, there we go. But if I try to add something that is not an integer, say hello, right, then it's not going to let me do that. If I took away my parameterization, it would let me do that, right? Because you can put whatever the hell you want in there. Right? Now, when you start processing that data, though, now what do you have to do? I have to check, is it an integer, or is it a double, or is it a string? And I have to be careful about that. I don't want to have to be careful. I want to have to be exact. Okay? So it's a list of, we call these Langle-Rangle, less than or greater than, right? Why it's a left-angled bracket and a right-angled bracket. So it's Langle-Rangle. And then there's the name of the list. It's a new array list, and then we repeat the Langle-Rangle there, and then we have parentheses here to create a new list. We'll understand all that later. Right? I just want to show you how to use it for now. System.out.println numbers. Right? It's ordered. I added 10, I added 20, I added 30, so therefore it's in that order. Right? What if I were to add something more? It automatically grows, by the way. Right? What if I added 42? And then I printed it out again. Right? Magically, 42 has been added to the end. Right? You can add things to the middle. Add things to a particular index. Right? So numbers.add, this one right here. I'll put it at index 0, and I'll put in 101. What that's going to do is it's automatically going to shove everything over to make room for 101 right at the beginning. Right? If you want to add it right in the middle, I don't know, let's say 0, 1, 2. Right? I'll add it to index 2, and I'll go ahead and go with 202. Now it'll be 101, 10, and then everything gets shoved over, and 202 gets put in right in the middle. Oops, I need to print it again, sorry. Cool. I can arbitrarily add anything I want to any location I want. I can also remove things. Remove via index. So numbers.remove 0. I'll remove the thing at the very beginning, that 101, and then print it out again. It removed it, shoved everything down automatically for you, so you don't have to do all that. Right? Cool. Size, right? System.out.println the numbers.size. Right? How big should it be after I've removed that guy right there? 1, 2, 3, 4, 5 elements, and there are 5 elements in there. Right? So we've got this basic what called CRUD. Create, retrieve, update, and destroy. I need a way to put stuff in. I need a way to retrieve stuff, take stuff out. I need a way to update stuff, say replace it, but that's just a remove and add. So how do I do a D, which would be destroy? How do I remove stuff? Right there. I've only touched the tip of the iceberg, by the way. If you go numbers dot, you've got several dozen different methods that you can invoke on it. If you wanted to sort it, if you wanted to reverse it, if you wanted to clear it out, remove everything, right? For example, clear here, right? That removes everything. How big is it now? 0, right? It cleared it all out. I don't want to clear it out though, right? I want to do some other stuff. I have a way to put stuff in, add an arbitrary index, remove from an arbitrary index. How about retrieval? Retrieve. So get the element at index, I don't know, 2. And x is equal to numbers.get element at index 2. And system.out.println x. So there's our list right there. What's the element at index 2? 0, 1, 2. So it should be 20. There we go. It did not remove it. Right? You're just retrieving it. It does not remove. Right? Like what you would want to get like 2 things at once, just to have 2 lines of code then. Right? Do you have a Python background? Okay. Because that sounds like a Python is wanting to do some tuple stuff. But yeah, no, you can't. 2 lines of code. There you go.
So in MATLAB, when you set any integer or variable, you can actually keep resetting it later on,
Mhm.
and it'll just compute one thing at a time, but you can't do that in this.
Like, what do you mean? Like, int x is equal to 10. You
Yeah.
can always go x is equal now 20.
Okay.
And what x, yeah, because it's a variable.
Right. Okay.
Now, that's a good question, though. What's the opposite of a variable? Something that doesn't vary is a constant, right? So if you want to create a constant in Java, in C, what would you do? Const foo is equal to 10, right? You would do something like that. There is no const keyword. It's a reserved word, but it's not actually used in Java. So what you do is you go final int x is equal to 10. There you go. Once it's final, that's it. You can't change it. X is equal to 20. Right? Ah, come on. Final int. Whoa, you're letting me do. Oh, because there's a syntax error down here. Sorry. I've already used it. That's why. All right, let's not use X. Let's use Y. There. The syntax error will be here now. Right? You cannot, or the compiler error technically, you cannot change Y once you've said that it's final. Right? That's the final word. Right? Otherwise, everything is a variable and can vary. Right? All right. Let's see. How about retrieving everything? Right. So for int I equals 0, I is less than numbers dot size I plus plus. We can use our old friend, the idiomatic for loop here, system dot, or let's get the integer x, int y is equal to numbers dot get I, and then system dot out dot println I, or not y, sorry. There we go. There it is, 10, 202, 20, 30, and 42, and then you're just getting them individually. Right? That's a lot to type though. Here's our enhanced for loop. Right? For an integer x, let's go y, in the collection numbers, just simply print it out. That saved me a few lines of code. It saved me from having to create a variable and initializing it and checking to see if it's less than a value and then incrementing it. And it also saved me retrieving the value at that index I. This is a much better way of doing it. The way that you read this is for each integer y in the collection numbers. Y gets updated every time you go through this for loop, automatically for you. Right? The language takes care of it for you. Right? This will end up printing out the same exact stuff as up there. Right? So 10, 202, 20, 30, 42. Right? That was this for loop right here. And then I didn't put a separator, but system.out.println, separator here. There we go. And you can see that it's the exact same behavior. 10, 202, 20, 30, 42, 10, 202, 20, 30, 42. But this is much better code because it's more compact. Yeah. Okay. Right. Enhanced for loop, or for some languages call this a for each loop, and even have a for each keyword, but Java doesn't. You just use the for keyword. Yeah.
So say like at the start, you did not initialize the list as for integer.
Mm-hmm.
And let's say one of the element is like the word hello.
Mm-hmm.
Would at the end of it, would it just skip?
Yeah, let's see what happens there. First of all, you can't pull it out as an integer because there's no guarantee that it's an integer, right? Second is you can't use an enhanced for loop like this. What you would have to do is something called type erasure, and you'd have to treat it as a generic object. Right? What the hell is this thing? I don't know, but it can print. Right? I can't add it to anything. I can't subtract it or multiply it because I don't have a guarantee that it's a number, but I can print it because anything can be printed. Right? Those are the consequences. And in fact, if you go back 20 years, that's how it was in Java before they introduced this idea of parameterization. So we don't like living 20 years in the past. This is how you should do it. Right? So that's a list. And by the way, it allows duplicates. So if I want to put 30 in there twice, that's perfectly fine. 30 is in there now twice. Right? It doesn't have to be like right next to each other or whatever, but you can have duplicates, you can do whatever. Right? Once you've seen the power of lists, do you want to continue using regular old arrays? No, right? Because now all like 90% of the work that you probably did in arrays in C is now done for you, right? And the other 10%, the other 5% of it can be done by something else. Numbers dot. Once again, there are dozens and dozens of methods that you can invoke on this, right? So if you need to do something with this stuff in your list, there's probably a method there for you to do it. Okay. All right. So there it is in the notes. The next one is a set. So you might have done a discrete math course or maybe have exposure to sets in math, right? If I were to write something like this, I'll go into math mode here for a second, A, B, and C, right? That's here I need explicit curly brackets there. There. That's how you would write a set, okay? It's unordered, right? I wrote it as A, B, or C, but that's the same thing as if I had written it as B, A, C. The only reason I write it in ABC is because, I mean, that's how we read, right? ABCs. That's the same thing. Those two things are the same set. And this is the same set as A, B, C. Right? In other words, sets do not have duplicates, right? Sets are unique values, right? This is the mathematical notion of what a set is. A set is an unordered collection of elements that does not allow duplicates. Consequently, it's not a math class, I'll go ahead and get rid of that mathy stuff. Right? But a set in Java is the same. No duplicates, right? And it's unordered. Ordered. Right? Consequently, with a list, I mentioned that you can sort it. We'll talk about how to do that later on. But can you sort a set if it's unordered? Nope, you'd have to make it into a list, and a list is ordered, right? So there's no ordering. If there's no ordering, there's no sorting. Sometimes people call these bags, right? Like you're just throwing stuff into a bag. Do you have any control over the ordering inside that bag? No, right? So sometimes they're called bags. All right, let's go ahead and let's do a little bit of variety here. What if I wanted a set not of integers? I could do integers if you want to, but let's do something else. Let's do a set of strings. Right? Names is equal to new hash set. Again, we'll talk about actual implementations later on here, but I'll go ahead and import the hash set, and I'll import the set. Right? And now names.add, I can't add integers to it because it's a set of strings. So I'll add my name to it. I'll add, I don't know, Craig to it. I'll add Michael to it. All right, and I don't know, let's see, Kyle to it. There we go. All right, okay. I'm just thinking of baseball players right now. Craig Counsell, manager. Michael Bush, first baseman, and now Kyle Tucker, our new outfielder. Right? Cubs. Yeah, I'm wearing my Cubs today. Okay. So there we go. All right, so if I were to print this out, would it necessarily be in that order that I added them? It might be, but more likely it's not. Kyle, Craig, Chris, Michael. Is that the order I entered them in? No, it's unordered. Right? Consequently, I can add stuff to it like I just did up there. I can say remove stuff from it, but I can no longer remove it from a particular index because there are no indices. It's unordered. There's not a first element at index 0. There's not a second element at index 1. They're just elements. So if I want to remove somebody here, let's go ahead and remove me, right? Then I have to do it by the actual object or the string. Right? There, I've removed myself. What if I removed it, tried to remove Chris, somebody that didn't exist in there already? No op, right? No op is short for, a noop or no op is short for no operation. It has no effect, right? It doesn't throw an exception. It doesn't make the program die, right? It just says, okay, well, there is no Chris, so he's removed, right? Done, right? So removal, or again, CRUD, put stuff in, take stuff out, retrieve stuff. Can I get the 0th element? Names.get, the element at index 0. There are no indices, right? So what I'm forced to do here is that enhanced for loop. For each string S in the collection names, system.out.println S. It seems like it's a little bit, less functional than a list, right? And I would agree, but that's the point, right? If you want the aspects of a list, that it's ordered and that you can have duplicates, then use a list. But if you want something where the order doesn't matter and you don't want duplicates, then you want a set. You can always convert back and forth between the two. Convert a set to a list. So a list of strings, names ordered, is equal to a new array list, just like we did before. But now instead of just giving these parentheses, I'm actually going to pass in names to it. Right? And now it's ordered. Right? Now it's a list. System.out.println names ordered. Right? And if I add a new person, names ordered, .add, let's see, Nico, right? And print it out again, you'll see that he gets added to the very end. Right? Looks like I removed myself. Right? There's the copy that's been changed into a list. There's the list after I have added Nico to the end. And everything that I just did with a list, I can now do with this ordered, names ordered, because it's a list. You can convert a list to a set the same way. So list of, I don't know, and let's do doubles now. Double values is equal to, here's a quick way of creating a list without having to add, list.of 3.4, oops, sorry, 3.4, 5.6, 7.8, 9.0, right, there we go. So it creates a list of those numbers, right? Now let's convert it to a set. A set of doubles, unordered values, is equal to a new hash set of the values. These are called copy constructors. We'll look at that much deeper later on when we do our own objects. And let me now print out that set. No guarantee that it's going to be in 3, 5, 7, 9 order. And it's not. Right? It's not the order that they were originally in the set. There's the original order. When I converted it to a set right here, it gives me unordered manner. Right? So list to a set to a list, back and forth if you want to. If you've got a bunch of data, you want to remove all the duplicates, dump it to a set. Now you want to sort it, dump it back to a list. All the duplicates have been removed, right? And you can do a lot of stuff with just a few lines of code. All right, so I will bring all this stuff over into the notes, and we don't have time to get to it, but on Tuesday, I'll blow your minds because you'll see that a map rules them all. Maps are even better than all of them combined, right? Come on, snap down, right? Because you've been thinking about arrays, right? Your entire matriculation here, where you've got 0 through n minus 1, right? If it's of size 10, it's 0 through 9. What if I told you that you don't have to go in order anymore? It could be 3 and 4 and 7. Well, what about 0? Who cares, right? What if I told you that you were no longer restricted to just integers? That I said that you can actually use what's called a key value mapping, right? So with a regular old array, you are stuck with integers mapping to whatever you're storing in the array, 0 through 9, right? And so they all have to be contiguous. They all have to be integers. Here we're going to have arbitrary values. You can map any key of any type to any value of any type. Right? You could map strings to a bunch of integers. You could map doubles to a bunch of strings. You can map anything to anything. Right? And once you've done that, you've opened up a whole new world of possibility with data structures, these dynamic data structures. And we'll look at several examples of where we come in really, really handy. Right? So maps, once you've seen maps, okay, that's it. I'm never using anything else ever again. Or more accurately, when you approach a problem, you'll first say, can I use a map to do this? And if so, then the problem is solved and you're done, right? If not, well, it doesn't exactly fit a map, then okay, is there a way that I can use a map in some other way to solve this? Because you'll end up wanting to use maps all the time. Okay? I'll see you on Tuesday after that, but otherwise I'll see you upstairs. Yeah, go.